problem 24, they say, here. In problem 24, they say, find the coefficient of variation. You could skip that. I'm not covering that in this course. No, thank you. We can do the range. What's the range? The range is, what is it? Do you guys know how to find it? Yeah, how do we find it? Largest data minus smallest. Okay, so that's a nice, easy formula. But there's other measures of variation that are a little nicer. Okay? And I want to show you how to do those. Okay? The most important and the most used is what is called the standard deviation. How many have heard that word before, standard deviation? Only about. I guess the problem with the standard deviation is that this is the this one has the most complicated formula we've had to deal with yet. Okay? And if you check back through, you're going to see some beautiful formulas. So let me go ahead and write the one you'll use most often, which I think is formula 3.4. Well, or 3.5, either one, but let me show you what it is. So page 101 has these formulas. Standard deviation is defined S equals the square root of, you guys know that symbol, right? You guys know this symbol. Now you do anyways. What's that mean? We're going to add up a bunch of stuff. What are we going to add? X, that means whatever number you have, minus, what's that mean? That's the mean. So you need the mean before you can compute the standard deviation. Squared. And then in the end, we're going to divide by n minus 1. Wow, what a formula. And then take the square root. What a beautiful formula. Well, no, it's written right there. So, which test? Coming up?
Yeah.
Probably. Be a good thing to know. But I don't know. I'm not so into memorizing formulas. I want you to understand what it does. So let's work with it. And then we'll deal with memorizing later. I don't care so much about memorizing. Okay? Let's do this. Let's compute the standard deviation of one of these sets of data. Okay, so we'll do one, and then maybe I'll have you guys do the other one before we leave. All right, so how do I do this? Well, you know what? Let me go through step by step what I would do. So I'm going to make a little column here that says X. And what goes in X are the data values. Now, I'm not sure I want to write them all out, because that's a lot of work. And then, you guys know your mathematics. When you see a big, ugly formula like this, what do you do first? Inside the parentheses, that's right. So I'm going to make another column here that says X minus X bar. And I could work out what those are, because that's what I do first. And I'll tell you what I'm going to do, I think. I'm going to skip and do problem 12. We'll do 24 in a minute, maybe. But the reason I'm going to do problem 12, and I'm going to suggest you watch and write rather than type. Unless you have this data still in your calculator, which some of you do, then you can do this if you want. But I have all the data for the freshman 15 in my calculator, which is problem 12. So I'm going to go ahead and get it out. Here's my calculator, right? let's see, on, oh yeah, so we have a lot of nice data here. What was the mean again of the freshman 15? 1 8/9, right? 1 8/9 was the mean. That was X bar. Okay, so what I can do now, if I go back and hit the stat button, I can edit a list. And so list 1, this is the list that has all of the data in it, right? I'm going to move to the right, and in list 2, instead of filling stuff out, I'm going to let the calculator do the work for me. Now watch how this works. I'm going to go up here, list 2, and I'm going to say enter. And when I say enter, it puts me down here. I can go ahead and type stuff in. And you're allowed to type in a list, you know, just some data. But what I'm going to do is I'm going to type in a formula. So watch what I'm going to do. I'm going to say, let's do, I'm going to hit second 1, and that types in L1. By the way, you could just stop here. If I press enter, look what it does. It puts the same list in L2 that was in L1. That's not what I wanted to do. Just want to show you could do that, right? L1 equals L2, or L2 equals L1. Let me not do that. I'm going to press enter again, clear this out. And what I want L2 to be is L1, everything in list 1, we're going to subtract what from it? Well, 1 8/9, which is 17/9. 17 divided by 9. I'm not going to press enter yet because I want to make sure that you understand what I'm doing. You understand what I'm doing? I'm taking every data point and subtracting the mean from it. Let's see what it gives us. A whole bunch of data points. What does the stuff in this list actually mean? Well, like 11 gave me a 9, but 3 only gave me a 1. How come? Basically, what's this measuring? Can you tell me what list 2 is measuring? All right. Now, so what are we going to do with this deviation? Well, we're going to square it, right? So I'll tell you what. Oh, and you guys were asking me, hey, I can't get these numbers to show up. It's probably because where you type the formula makes a difference. If I just type the formula when my cursor is here, it doesn't work. It gives me an error. But if I hit the up arrow and go on top of L2, and if I press enter, it puts me down here, and this is where I type the formula in. Here, I'm going to do this again. I'll go on L3 just to show you how it works. And do you see how my cursor is on top of L3? I press enter. And you know what I'm going to say that L3 equals? I'm going to say that L3 equals L2. So I'll press L2. And you know what I'm going to do with it? I'm going to square it. So let me square all those numbers so they all become positive. There they are. Wow. There's a lot of deviation in that first one. Okay? And then what do? Well, I have to take all these things that are being squared. Let's look at the problem. Oh, wait, where am I? L2 was the same as L1, but I squared it. So L1, oh, what did L2 equal? No, I think it was L1 minus the mean, right? Yeah, because 17/9 was the mean. L3 was, I took L2 and squared it. L2 squared. Yeah, just a second, please. So I guess the L3 column is this, right, guys? It's x minus x bar squared. Is that okay? So what am I supposed to do next after I have all these x minus x bar squareds? Well, before I divide, there's one more symbol up here. I have to add them all up. Yeah. You had a question, I'm sorry. No. it means what we want is the total here. We want the total. So what am I going to add? That's a good question. Here. I have to add all this stuff up. No, just L3. Because L3 is the x minus x bar squareds, right? Wow. Yes? Yeah, because I don't want to sit there and add them by hand. So what I can do, let me hit second quit. And actually, look, I actually showed you how to do this, but not yet. See, it says sigma x. Remember what sigma stands for is add them up. So watch what I'm going to do. I'm going to hit stat button again. I'm going to do some statistics. Calculate. So I go to the middle with my arrow. One variable stats. And you're allowed to tell it use a different list. By default, it uses list 1. I'm going to tell it to do one variable stats on list 3. How do I do that? I hit second 3, which gets the L3 up there. Is that okay? And I press enter. Now, x bar doesn't mean anything. But this is the number I want. It added everything up, and it got 279.77. Okay. So I'll tell you what I know. 279.77. All right. So I know that the sum of the x minus x bar for this problem 12 is equal to 200, what did I say? 279.77. Right? What a mess. And then what am I supposed to do with that number? I'm going to take that number and I'm going to divide by what? N minus 1. What was N? N's how many data points there were. N was 18 for my data. I'm pretty sure. Let me double check that. Okay, so I divide by 18 minus 1, which is 17. And then what do? Take the square root. And that will equal the standard deviation. Wow. All that. Okay, what a mess. So, let's see. Can I do that? Yeah, I suppose so. Let's do, with the calculator, I'm going to hit second quit. I'm going to clear out, just get a blank screen. And I want the square root of 279.77 divided by, and I'll just put in 17. Is that okay? That's going to be S. 4.05. 4.06 if I round. Now, did any of you guys notice this? Here. Let me do this again. Let me hit the stat key. Calculate. One variable statistics. And let me do list 1 again. That's where my data was stored. Okay. Hey, you guys see that number? 4.06? Where is it? SX. So when you do one variable stats on a list, it gives you the standard deviation. So what was the point of doing all that? Well, I wanted you to see what the heck it was doing, right? S. S. S stands for standard deviation. Now there's another letter there, right below S, and that's sigma. That stands for standard deviation also. But notice it's a slightly different value. We're going to stick with S. Okay? It's used for a different purpose. We're going to stick with S. All right. So what's the game? Well, I want to go back to problem 24. So let's see. we had one single line, or then we had three individual lines. And I remember the mean was the same for each, and the median was the same for each. Standard deviations, anybody? 1.82 was the single line? Was the triple lines? So this was 1.82 according to my experts in the audience. And how about the single line? 0.4. Okay. So what does this tell you? This tells you that the three individual lines, the data is more spread out than the single line. Okay? Now, besides that, I want to tell you a little bit more. Okay? Is it possible you could go to the bank and wait for 30 minutes before you get taken?
No.
You say no?
I've never seen anyone wait 30 minutes.
Well, I just asked, is it possible? And I had some people say yes, maybe from experience. It definitely depends who's in front of you. Depends what happens to the teller, how much of the change they spill everywhere, right? I mean, you know, there's a lot of things that could happen. Is it likely it's going to take 30 minutes? No. Let me tell you a little rule of thumb for statistics. And that is, it is unlikely, it is uncommon for something to be more than 2 standard deviations away from the mean. It is unlikely or uncommon for something to be more than 2 standard deviations away from the mean. What was the mean in this problem? 7.15. Okay. Guys, is it likely when you go to the bank that you're going to have to wait 10 minutes?
Yes.
Well, we even saw in our sample someone did wait 10 minutes where? The 3 individual lines. What about the bank with the single line? Is it likely that you're going to have to wait 10 minutes? Is it unlikely? Why would you say that? Well, just because it didn't happen doesn't mean it's unlikely. But I can say it's unlikely if I know the standard deviation. Because I can take that mean, right, x bar, and I can add 2 standard deviations to it and get a value. So let's see what that equals. 7.15 plus 2 times, let me call it 0.5, even though I know it's not quite right. I just rounded it. 8.15, right? Is it likely you're going to wait 10 minutes at this bank with one single line? And the answer is no. Why no? This is what I'm trying to get across. It's more than 2 standard deviations away. Matter of fact, it's like 4 or 5 standard deviations away. It's very unlikely, according to the data, that you will wait 10 minutes when there's one single line. By the way, it's also very unlikely you'll wait 4 minutes. Okay? Because that's more than 10 standard deviations. I mean, it's more than 2 standard deviations the other way. Okay? Standard deviation tells you how spread out it is. If you're more than 2, it's unlikely. If you're more than 3, it's very unlikely. Okay? And again, this is a rule of thumb. We'll see more. We'll learn more about that as we go on. Yeah?
So that's the way to get the standard to find out if it's over 2 standard deviations is the answer.
Yeah. This tells you kind of how much to add there. Right.
Then where did you get the 0.5?
Oh, I guess I could have added 0.476 here, because that was the standard deviation.
Oh, that's...
But I decided to do 0.5 because I just rounded it. Yeah. know, I have 2 minutes, and I was going to give you one more rule of thumb if you want it. Okay, everyone's packing up and stuff. It's kind of disturbing to those that are listening. That's okay. Rule of thumb. Rule of thumb. And maybe I'll do that here. Here. We're not going to do problem 28 right now. Let me do it here. So one last rule of thumb. S is approximately equal to the range divided by 4. Now, what the heck is a rule of thumb? A rule of thumb means this is something you could figure out without a calculator. But it's not quite right. And it's not always right. But it does a pretty good job. Let's see if it works here. I don't even know. I didn't try it before class or anything. What was the range of data for either of these? The single line. We had that somewhere. What was our range? So it was 7.7 minus 6.5, and so it was 1.2, right? Well, what happens if I take 1.2 and divide by 4? I get 0.3. Is that the standard deviation? No, but it's close. Gives you an idea of what the standard deviation is, how spread out the data is. Let's try it with the 3 individual lines. What was the range? Oh gosh, it was 10 minus something else. 4.5, I think, right? 4.2. So it's 5.8. If I divide that by 4, I get 1.4 something. Again, that's not quite right. The actual standard deviation is 1.82. But again, it gives you an idea of how spread out the data is. This is a rule of thumb our book presents. Okay? We are out of here. You guys have some homework to do for Tuesday, but also enjoy the Labor Day weekend. And I'll see you when we get back.